go to Schoology, click on 02 forces, refresh your page. Was there any questions for the previous one? Okay. Go ahead and refresh your page in Schoology. Go to 02 forces, and let's learn how to do the second type of physics problem using our new equation. A 10 kilogram box is resting on a table. Determine the weight of the box and the normal force acting on it. If you push down on the box with 40 newtons, determine the new forces on the box without breaking the table. And then if you pull up on the box with 40 newtons, what is the new normal force on the box without lifting the box? So let's get some definitions first. Weight is not just how many pounds you are, or how many pounds something is. Weight is actually the amount of force pulling down with gravity. So your weight is going to be different than it here on Earth than it is on the moon or Mars or Jupiter, because the gravity amount is different on each planet. So stop thinking of, well, in this class, think of weight as how much gravity is pulling down on you with in a downward direction. The word normal force is just the opposite of that weight. Okay? So we're going to find the weight of several different values, and when you want to find the normal force, it's just the opposite of weight. Let me show you an example. Draw yourself a little box that's on a table. I was able to find a Nike box on Google Images. Now this box weighs 10 kilograms because the problem tells us that. What is the weight of this? What is the weight that's acting on the box? Now you're not just going to say 10 kilograms because I need to know how strong the pull is using gravity. So we're going to use the same equation, F equals ma. So here are some definitions that you can use to help you in this process. F little g means weight. F little n is the opposite of weight, the force that's opposite of weight. Maybe I'll add to this. Force of weight, and then the force that's opposite of weight. Now when I explained this to period 1, I kept using this visual. We're all pulled down by gravity, but we're not crushed by gravity, right? Our bones aren't flattened. Our faces aren't smashed into the ground. We have something acting against gravity, helping us stand, helping us walk, letting our lungs expand. So that's called normal force. It's the force opposite of weight. So the equation we're going to use to find the force of weight is going to be F equals ma, and more specifically, F equals mg. Mg is gravity, negative 9.8. A lot of definitions today. Now this next picture, I'm going to ask you to draw arrows showing how weight acts on the box and how the box goes against the weight as well. So the next picture just shows another shoebox and a box and a table. But I'm going to add arrows to my diagram. Where are my arrows? There they are. So this black arrow is the weight, and then this blue arrow is the normal force. Just like our definitions say, there's something pulling you down, but something that's keeping you from getting crushed. Anytime you have this phenomenon of an action and a reaction equaling to each other, That's called Newton's third law. Every action has an equal and opposite reaction. This is something every single high school will focus on for a long time during physics. And it makes sense. If you push somebody, you actually get pushed back also with the equal amount of force. You just might be heavier than that person or lighter. And that's Newton's third law. The same thing's happening to this box. The fact that it's not crushed means that the normal force is equal to the force of the weight. Now when I label this, I'm going to use the equation Fg equals mg. Let me see if I can get this right. F equals mg. M is the mass, 10 grams. G is the gravity, negative 9.8. Let me get a student to calculate this. Evelyn, grab a calculator. Give me 10 times negative 9.8. Negative 98. So that's the weight. I want to make my 9 a little bit better without getting my tablet out. Okay. I'm sorry if that's really hard to see, but that's my 9. If weight is 98, force, normal force is the exact opposite. So what's the opposite, Evelyn, of negative 98? Positive 98. So I'm going to put this at the top arrow, and then F sub G is my downward arrow. Let's do letter number 2. If you push down on the box with 40 newtons, determine the new forces on the box. So let's go ahead and redraw our arrows. I have a downward arrow of weight. I have an upward arrow of the normal force. But this time, I have an extra arrow that is negative 40, because it's going back to Earth. So what is the new weight if we push down on it? And what's the new normal? We're going to combine what we solved earlier with Evelyn and add this value, negative 40. So Elijah, grab a calculator. Let's take our negative 98 that Evelyn got for us and subtract 40, because this box is getting pushed down on. What's negative 98 minus 40? Negative 138. That's the force of the weight, which means what's the normal force, Elijah, if the box is not getting crushed? It's just resisting the weight. It's going to be the opposite of the force of the weight. What's the opposite of negative 138? Positive what? There you go. So let's go ahead and place that next to the upward arrow. Wish I could do this better. So that's our new normal and our new weight. 138 going up, negative 138 going down. Last question. What if you pull up on the box, but we're assuming the box is not coming off the table? You're just starting that motion. What's the new forces? Well, always start with the weight, because normal is just opposite of weight. Force of G is going to be, let's do our arrows first. There's our normal. There's our weight. And here's my new force applied. It's positive 40 this time. Sorry, I'm showing you the answer early. But it's going to be force of the weight equals negative 38 plus 40 this time. And Jack, if you could do that for us in your calculator. Is he here? Yeah. Negative 58 is our new weight. And the opposite of negative 58, Jack, is 58. And that's our normal force. And that's how you solve for Newton's third law.